Welcome back, it's True again with another phyTech graphics development guide, and today we're going to be looking at Kivy. Kivy is a Python-based graphics stack, and so it's very easy to integrate. We're going to get right into it today. So let's navigate over to our Ubuntu 20.04 virtual machine. I'm going to access the terminal here and navigate into the BSP that we built in the past. Like so, source that build environment. This is the default BSP. In order to integrate Kivy support, we're going to navigate into the sources directory, and we're going to clone the Kivy meta layer that we have provided, like so. We're going to make sure to grab that scarf gap version here for PD24.1.0. Now let's take a quick look at what that is. So in here we're going to have a new recipe for images. Looks like it's the phyTech Kivy demo image, similar name to the Qt6 demo image, which is what we support by default. So we could build this to integrate all the support here, but let's take a look at all the individual components. In recipes graphics, this is introducing some Wayland support. Looks like this is going to be that Weston init change that chooses the LVDS display over the HDMI by default, so we should expect this Kivy demo to just start right on the display upon boot. What else do we have in here? Looks like there's a recipes example. What's going on in there? This is providing the Kivy application itself. Take a look at that. Looks like it's providing a systemd service for our Kivy application. The application itself is provided here in this Kivy demo repository. And we could take a look at that systemd service as well over here in files. That's what it looks like. Looks like there's a number of recommended environment variables that we're going to want declared in order for the Kivy demo to run. Recipes dev tool, what's in here? Looks like the Python 3 Kivy support. So Python 3 has Kivy. Kivy is a module in Python 3, and so this is being provided here, a recipe for that. And so we could assume that this support is enabled in the image. We can actually just confirm that real quick. Looks like Python 3 Kivy and the demo itself, the two dependencies. So this is going to require Python 3 support, of course, the demo, and then the support, the Python 3 Kivy module for backend support. All right, so now that we have our meta layer cloned, we can just navigate back to the build directory. We do big layers, add layer to the directory. Easy peasy. And then we can go ahead and kick off a build and make sure to build that new image provided in that layer. Once the build completes, we can take a look at our generated binaries here in the deploy directory, images, and then the machine we built. Here we have a phyTech Kivy demo image. We're going to go ahead and flash that to an SD card. Grab my SD card, get that plugged in here. Case here I'm working with VirtualBox, so I have to make sure my SD card reader is connected to my host, my Linux host. Now that we have it, let's make sure we identify what disk what it enumerated as. So here's dev SDE. We're going to go ahead and make sure that that is unmounted. And this is a .wic.exe, so we're going to have to actually, before I can run dd, I have to exe it on the command line, decompress, and then we can dd it to dev.sde. All right, and now that finished flashing to the SD card, let's go ahead and use that to boot. So switch over to my hardware here. recall that we had that Weston config changed in the meta layer here by default at build time, so we should see a Kivy demo start automatically on the touch display. Hopefully. There we go. And yeah, this is a Kivy demo. Very basic, provided by phyTech here. There's a catalog here where we can kind of look at all the options for navigation and all the pre-included widgets. It is multi-touch as well. Perfect. Now let's get into creating our own demo. I'm gonna log in here into the console, and recall that that I believe the demo was called Kivy phy. If you don't remember, I like just do a keyword search, system control grep for Kivy. Looks like that demo service is provided here by Kivy phy. So we can do a system control stop, and our demo should disappear. Perfect. And now we can go. We're free to go ahead and develop our Kivy demos, our example code here right on the target. We could. Kivy is also open source. We could run Kivy code right on the host, but since it's already here on the target, it's very convenient for just on-target development. We'll go ahead and do that. So how do we get started? First, we're gonna have to create a Kivy example. So we'll do let's see, hello world.py, and I have some code prepared for us off screen here, like so. In order to activate that Kivy module, we just got to import Kivy, and we can build our code with this kind of starter code here. How do we run that? We just do Python 3 and then hello world.py, and when we do that, we should immediately see the demo just appear on the screen. Perfect. Now notice that this is a smaller window, and this goes back to those environment variables we saw in the systemd service. We could go ahead and declare those as well. Key ones here, we can set full screen to auto. There's some comments here. I just grabbed this out of the guides. You could ignore those. The shell here will automatically ignore that. And now we can go ahead and run that example again. Should see that it's now full screen. Perfect. Let's add a button to that and hook that up to a GPIO. In order to do that, we're going to need the GPIO-D Python module. We're not going to have that available here by default, but we can go to our BSP and add Python 3's GPIO-D module very easily. All we have to do is go into the conf/localconf. Now we get to the end of the file and add this line, image install. We're going to append to that variable, and we're going to add the Python 3 GPIO-D module like so. That is reflected in a recipe provided by default here in scarthgap. We can just confirm that GPIO-D. We should see a recipe for that. Perfect. So just by enabling that module here like so, we should have this available in our resulting image. So we'll have to rebuild the image to add GPIO-D functionality here. So we can go ahead and do that with the bitbake phytech Kivy demo image again. Once that wraps up, we'll have a new image with that Python 3 GPIO-D module included. We'll have to flash that to the SD card again. So real quick, we're gonna go over here, go ahead and power off this guy safely. Then we'll go ahead and flash it again. Oh, but make sure to unmount that. You always have to do that unless, otherwise you'll run into a corrupted file system and you won't be able to boot. So make sure to unmount first, and then we can go ahead and flash that. And there we go. Okay, let's boot that resulting image. All right, and let's double check that we have Python 3's GPID module. We can just do a quick check like this, see if that module loads. Okay, the module is being found. There's no main function in it. That's fine. That's all this error is telling us. So we are here confirming that GPID does at least exist. Let's go ahead and create our button demo. Ooh, we don't have them on target, but we do have VI. Have that code pre-written off screen. There's a lot more code here. What is all this? So here we are building on that hello world from Kivy. Here we're introducing a grid layout, adding a button to that. We still have the hello world text from before, but we've added a button to the grid layout, and then also defined this on pressed handler button pressed. Define that down here. It's just calling LED on and off depending on the state of that toggle button. And then we have some GPID functions being leveraged in these LED on and off functions. So we should expect our GPIO, which we define here at the top, to be toggled on that button press. Oop, the right first. And let's go ahead and declare those variables again, giving us that full screen experience. And then we can go ahead and run our button press demo here. Sweet. And I should expect the LED to toggle on and off on presses here. Excellent.